We have Matt Eidelberg, and he's going to talk to us about SniffAir, which is an open source wireless security framework.
So, as we mentioned, we're here to talk about SniffAir. So briefly beforehand, who am I? So I'm Matt Eidelberg. I am a security consultant for Optiv's attack and pen team. My co-author, who unfortunately is unable to be here today, but is in spirit with us, Stephen Derricott. He's a security consultant at Optiv as well. You can see our Twitter handles. Feel free to ever ask us any questions about wireless or anything regarding the tool if you ever get a chance to use it. So before we talk about the tool, let's talk about wireless pen testing. Mainly, what do we look for? So as testers, first thing we need to do is figure out what the lay of the land is. And we do that by fingerprinting and profiling the wireless access points, as well as the client devices used in the environment. From this, we can also then determine and identify rogue access points that we can help eliminate for a client. These are usually maliciously or inadvertently spun up access points that can allow unauthorized access or may not meet the company's policy standards for security. We also analyze the traffic between the access points and clients, looking for any misconfigurations, weak encryption, or anything that can be exploited. Once we have this information, we can then delve into developing attack vectors to be used. So how do we get all this information? There's one of two ways we can do it. We can get it by actively scanning and sending packets and information to clients and see how they respond. Or we can passively listen on all the traffic in an area to gain an idea of how things operate. So the first thing we look at are beacon frames. Beacon frames are used by access points to announce their presence in an area. So that way devices know that this area is where I can connect to the said access point, SSID. The MAC address, which is what they contain in each of these packets, is the physical hardware address used to identify that specific device, as numerous wireless networks can have multiple access points broadcasting the same network name. The SSID, as I just mentioned a few seconds ago, is the unique name of the wireless network. In addition, the other information access point beacon frames broadcast is the capability information. Now this information contains the channel information that they sit on, the encryption that they use, as well as authentication and other data rate information that the client needs to be compliant with in order to properly authenticate. The next thing we talk about are probes. There are two types of probes that we look at. The first one, probe requests. These are packets sent by clients looking for an access point or a network, a wireless network in the area. So they broadcast out in a large arc range, looking for is SSID X in range. They'll do this, and these packets contain the client's MAC address, as well as the name that they're looking for. If they do not find an access point that responds, they move to the next channel and repeat this process until they receive a response from an associated access point. Those responses are sent through probe responses. These are sent by access points directly to, with the intention of going directly to that client that sent out a probe request prior with a matching SSID name. These packets contain the SSID, the supported rates, encryption, and other authentication information. The last one that we focus on as testers is the EAP protocol, which is Extensible Authentication Protocol. It handles the authentication where credentials or pre-shared keys are passed. Multiple different types of authentication types are used by PEEP, the protocol. In most cases, we see this a lot with enterprises, is the use of a radius server. So the access point itself doesn't do the authentication. What happens instead is that they pass the information on to this radius server, and the radius server does the authentication check to ensure that the credentials are valid and that they are allowed to log in. Once this is done, based on the success or fail, the radius server sends a message back to the access point, and the access point acts as an authenticator or a gatekeeper, allowing or denying access for that client. So, fingerprinting. As you can see, this is an example of a commonly used tool for testing. You can see all that information. Might be a little blurry for people up at the back, but there's all the information, but it's just in a confusing way to kind of read it, and it's sometimes hard in real time as this stuff is always changing. It's hard to get a sense, and stuff might even fly off the screen often. So briefly, you can see in this example, you can see all the access points. That's over on the top. I don't know if you can see the number 1. We tried matching it up, and that's all their physical addresses. Then you can see the power. So what we refer to as power is actually how close you are to this access point. The lower the number, the closer you are. The higher it is, the farther you are away. Next, we show what the access point channel is sitting on. This is important so that way the clients know which channel to set themselves to. But this also allows us to know the information when we're trying to create some malicious attacks, such as an evil twin, where we have to masquerade as a legitimate one. As well, the type of encryption and ciphers being used by the access point, and authentication type. You can also see at the bottom, you can see all the probe stuff that we were just discussing about probes and probe responses. You can see here that which devices have been associated to which BSSID, which is the MAC address of the access point, as well as what they were looking for. Now, a lot of tools, what they don't notify you about is that if they discover a hidden access point, which is one that does not broadcast, this causes a client to send more and more packets looking in an area. And if an access point receives a valid probe request with that SSID that they're associated with, they will respond. So a lot of tools, they just will parse that for you and change a hidden SSID up at the top to whatever the value was. So you may not know that some of your access points are broadcasting or acting as a hidden access point. And we kind of will demonstrate the features and what we do with that in SniffAir in a few moments. So as testers, these are the common attacks that we see. These are not all of them. As recently you all might be aware of, there have been some recent new vulnerabilities discovered with the WPA protocol. But these are the common ones we typically see people use out in the wild. These are also the common network setups that we commonly face or have to kind of look at and assess. So the first one is a captive portal. So this might be open network or one that uses a pre-shared key, authentic encryption. Users are then presented with a captive portal that might be domain credentials, other credentials, or just a shared key phrase. And then authentication is done to this web app. The other one is pre-shared key PSK. This was initially designed as more for home users, but we do see it a lot being used for guest networks where everyone in the company knows the password for this. And you don't need to have domain credentials. It's kind of one of the things we see a lot, and it really comes down to how strong is your password for it to be secured until recently. The next thing we see a lot more in enterprises is 802.11x, where EAP authentication is using domain credentials. So we see 4 common types. The first one is called EAP fast, in which we see this a lot with Cisco devices, and it's in conjunction with EAP chaining, where you have a series of authentication mechanisms chained together, and if each one is met, then the device is allowed access to the network. And this could be password or device password that's sent automatically, and then Cisco's VPN product instantly uses the valid domain credentials to log in. And if both things are met, the device is allowed network access. PEEP is known as protected EAP, in which credentials are sent through a secure protocol, a secure tunnel before, so that way it helps eliminate any eavesdropping attacks. EAP TLS uses TLS certs that are assigned to each device. And so the weakness there is relying on the TLS cert in encryption. However, no passwords or usernames are passed. And EAP TTLS, we see that, which is a combination of PEEP and EAP TLS, where both credentials and a TLS cert are used. Usually the TLS cert is created first, this tunnel, and then that tunnel is then using secondary authentication credentials. So, what is SniffAir? SniffAir is an open source wireless security framework. Its primary purpose is to collect, analyze, and manage large amounts of wireless traffic to allow us to perform wireless attacks against clients and networks. How it works is you can feed it either live data or offline pcaps. And once you've done that, using the database we developed using Scapy, it breaks down each of the packets into one of 4 categories: access points, probe requests, probe responses, or enterprise packets. Once that's done, it then parses out all the information I briefly discussed previously, storing it into our database. Now, as I mentioned, these access points and clients are always sending out numerous amounts of the same type of traffic, so we only look for the unique values and store them. That way you don't have to go through the multiple duplicates or 100 of the same packet. You can get down to what you need to see. So I think I've talked enough. Let me actually show you this tool. Everyone can see that it's not too small? Okay. So first off, we load up a workspace. I've already taken the time to load up, as it sometimes a large pcap can take a few minutes, or even maybe 5 to 10. So once you've loaded up a workstation, maybe you've done this, you've collected it, and then you've gone back to look at it. It actually gives you a small dashboard of what the top access point SSIDs are and how many of them there are. If you've specified, there's also a feature to in-scope ones. A lot of times you might see 300 different access points. It might be from a coffee shop, or if you're in a busy building or you share office space, you might have numerous of different networks all around you. To help eliminate that, we have an in-scope feature that will also give you a dashboard as well. So let me show you the first table. The first table we have is the access point table. So this is in demo mode. As you can see, there's over 270 in this single pcap file alone. But to give you an idea, you can see, oh, actually it's partly cut off. Actually, no, it should be fine. The SSID that they're broadcasting, the MAC address of that device, the BSSID, the vendor who actually manufactures it, like Cisco or anyone else, the channel that these access points are sitting on, and the power. As I mentioned, because of how many duplicate packets you might get, SniffAir only records the lowest value, i.e. the closest, when you were the closest to that access point, and records that into the database, so that way you have how close it is to help eliminate any ones that are farther away. You can also see the encryption, the cipher, and the authentication. The next table I'm going to show you is the probe request table. So, like I discussed, this table only captures the client's MAC address, who made the device, and what SSID they're looking for. The next table I'm going to show you is the probe response. That one might need to be zoomed. There. So you can see all the information. You can see the SSID of that access point, their address, who made them, the channel, type of encryption, and who they're responding to, i.e. who sent the probe request at the client, from the client that they're responding to. Finally, the enterprise EAP table. So here, there's a systemic issue with EAP in which usernames, and when you do a domain or even off radius, might be a separate set of credentials outside of domain, but whenever it comes down to password and usernames, it actually will send the usernames first before encrypting the passwords, sending them in clear text. So as pen testers or even attackers, there's a lot of usernames flying around a business that can be used for other attacks, which we'll talk about in a little bit. But here you can see the client that sent it, the username, and which access point they sent it to. You can also query for certain things. Maybe not, you don't need to see a whole table, but you want to see, for instance, show me all the SSIDs across all tables. So you can do these types of queries. You can also do ones like vendor, encryption, and other. So I mentioned before that there's an in-scope feature because obviously, as you can see, there's over 270 access points. There's probably lots of duplicates, but even still, it's probably not what you're looking for. You want to see what access points you want to test. So there's an in-scope feature. So what you do is, using this command, you can actually add an SSID to your in-scope, and this creates a separate set of tables for both access point, probe request, response, to view and kind of get a clearer, smaller, look at the smaller, more detailed picture. So, as an example, so we just added this one. So we do show table in scope AP. We see only the ones that are part of the in scope SSID, and you can add multiple ones. For instance, we can then add another. And we also have a great dashboard, so that way you can just see this as a high overview, or maybe if you need to give this to your client to get an understanding of what their environment looks like, using the SSID info. So this command shows you all the access points, who manufactured them, what are the common channels they all sit on, and the type of encryption used. So for this first one, you can see that it's an open network. Here's all the access points that it uses, the channels that it sits on. And then for Star Labs, you can see the type of encryption, the channels, and all this stuff. This helps you give you an idea of what you're looking at. We also have modules, some used for active exploitation, some of them for passive to gain more knowledge or even to do vulnerability assessments. Right now we only have a few, but in the next few weeks we're actually going to be rolling out a next major patch with a lot more modules. But to show you the first one, we'll show you the hidden SSID. So as I mentioned before, this module, what it does is it compares the probe requests and responses to access points that are showing up as hidden in our AP table. So what it does is it compares and looks, but what also it does, it also records them and changes them in the database. So when we go back to that table, we will see that those access points have been changed. And I'll show you in a bit, but before that, I want to show you that you also can then record all those that you've discovered that are hidden by using the show hidden SSID table. And now you have a list, a concrete list of the ones in the area that are set up to be hidden. We also gave you the ability to make your own queries, because sometimes you might need to see something additional. You might have something that we haven't thought of. So using the query command, you can do your own SQL-based queries on the whole database. So as I mentioned, we also update the access point table, so let's verify that. So we'll do select. Bear with me. You can see that this query shows all access points, all in the access point table that have this BSSID. So previously, it was registered as a hidden. Now it's showing up as the actual name. So I do have a couple of videos, just in case, but this to also help of some of the attacks we have currently in here, as well as, if there is time, a live demonstration. So this first attack is what we call auto-EAP. It's an automated EAP brute forcing attack. Brute forcing credentials has been something as pentesters have done for a long time, but the ability to do it over wireless has been very limited, especially for enterprise. So this video outlines, it's kind of blurry, let's see if I can't. See if I can't. Can anyone actually read that? Okay, just give me a second here. Is that any better? From my view, it's okay. So. Oh. There we go. Of course, now I can't. So unfortunately, I just can't get it to properly be seen, but I'll try to. So what this is showing is an example of the access point table. And what you can see here is the list of the access points in this demonstration. I'll try to kind of walk you through it, as I know it's a bit blurry. So I'm not sure if anyone can see this right on the bottom side. We've discovered a list of usernames, and as well as the access point that they are connected to. So what we can then do is load up our module. AutoWeep. The module is called AutoWeep, in which, I know you can't really see it at the bottom here, but it uses the same type of system that you see in like Recon NG or anything else like that, where you set the variables. So you can see set interface, set the SSID name. So this one, because unfortunately it was cut off, is called honeypot. We're going to set the encryption. And then the key management. As well as a password we're going to try to brute force. So in this case, we're going to use one that probably no one uses, at least I hope not still. Unfortunately, it's cut off, but you can see all the variables have been set, and then we're going to begin our attack. So on this side, what you can see more clearly is an actual Radius server's output. So you can see, as it exploits, you can see passwords being attempted and success or fail messages. So this is simply taking all those usernames that were discovered from the insecure protocol being passed over the air. You can also feed it in your own list off that wasn't part of the database, something that maybe you do through some OSINT or other information gathering if you have a comprehensive list. And then once you've done that, there's actually a loot table that stores and records all your successful. Unfortunately, you can see it's cut off. But from there, that's one of the attacks we have in this framework. The next one I'm going to show you is, now this one probably will suffer from the same issue. Yeah. So in this one, it loads up the same way we've done before, where you load up the workspace. In this case, we're loading up captive portal demo. And I'll try to zoom in on the key parts of this that we're trying to highlight. So right now what we're doing is we're looking for any access points that have the encryption as open. And we're just going to show you the top 5. So we can see that haha is the most common one out of this query, and it sits on channel 1. So similarly, we've loaded up the captive portal module. Now currently there's only one template we have, which is a Cisco login portal. We're just going to set the interface and the SSID. And the channel. Now what's great about this attack is for mobile devices and some versions of iOS, once they've connected, if they've manually clicked on our access point to connect to it, or they've been reassociated to us, it instantly will load up the page as if it was they did it themselves. So let's wait. It will set up the DNS and stuff, and you can set up in bridge mode if you want to do SSL stripping or other man-in-the-middle. But you can see right here, once we've clicked on ha ha ha, it will instantly load up the malicious page. So we don't have to get the users to actually try to go to their web browser or check their email, and then all of a sudden they have no network connection. It just instantly pops it up, increasing the success rate of people disclosing their credentials. And of course, all these credentials, like I mentioned previously, are stored in the loot table, which you can query, which we'll see right here in a second. So what I'm going to do, hopefully this works a lot better than those videos. First time the videos failed. I'm going to try do a live demonstration of another attack we have here, which is an evil twin, in which we set up an access point to masquerade as a legitimate client. And we get people to connect to it, and we can get them to disclose their MSChap hash. And those hashes is the same as domain credentials. We just crack them the same way. You can use Hashcat or John the Ripper. So I'm going to set it up, and if you guys want to connect to it, you'll see the username and stuff. I just ask, please keep it PG-13. I guess now would be a good example. I can zoom in. So you can see right here, whenever you use a module, you always have variables you have to set up. First one we'll set up is the interface. Then the SSID. The channel. We'll make sure everything has been set. So feel free to connect. Like I said, just please keep it PG-13. And what you'll see once we have someone connect is you can see that the MSChap v2 hash is viewed. It's also stored for us to then perform password cracking on. So we have one person connect. Were you not prompted for credentials? Okay. It looks like the demo gods are not in my favor. Just give me a second. Actually, what I'm going to do, Okay, so this demo is not working, unfortunately. But what you would see is the username followed by the MS-Chat v2 hash. Oh, there we go. There we go. So what you can see right now is the hash, and in a JTR format that you can instantly pipe in to begin your password cracking. So this is one of the attacks, most common ones we see or perform a lot. There are other ones that we perform that we'll be adding in shortly. Actually, in the next few weeks, we'll be releasing a major patch with a lot of more modules for both attack and vulnerability assessment. I'm just gonna just kill this. So to recap, so SniffAir is an open source wireless pen testing framework. It allows you to parse and collect data, pulling important information out of each packet and storing in a database to allow you to perform queries and to get an easier understanding of the lay of the land, as well as focus in on the access points or clients you just want to test. There are modules, as we just tried to demonstrate, that allow you to both do additional analysis as well as perform wireless attacks against clients and access points. As I mentioned, we're releasing a patch, and these are kind of the things that we're looking to address. We're always looking for new ideas for both passive analysis as well as active attacks. So some of the ones that we're looking to implement are also reporting and post-X modules, like man-in-the-middle, SSL stripping, stuff like that, as well as some of the other common attacks, like the GTC downgrade, as well as more captive portals. You can follow us on Twitter. We are very active with regards to any bug reports or issues you guys may have with the tool or any questions or ideas. You can follow us on Twitter or through our GitHub. Any questions? In what sense? Like for detection of a pineapple? No. Mainly because of the reason we decided to design this was for our testing purposes. A lot of times clients don't like the fact that we show up with pineapples, so a lot of the stuff we started developing ourselves. So that turned into like managing 20 to 30 little Python scripts or C or Go scripts. So we decided, what if we unified it into a framework where everything is integrated into one?
You guys working on a crack module yet?
Yes, we are. We've been adamantly looking at the stuff, going over the information, and hopefully we should have something. As they're releasing it, we're looking at it. We want to first test it and make sure there's no hiccups or bugs and that we don't cause any issues. That's one of the biggest things, is we want to make sure we're not inadvertently exposing our clients to more issues when we test and assess. Any other questions? Okay. Thank you.